Hello guys. In this video we are tackling another example on the RL circuit. So we're just maybe solidifying more on this concept. So we have a sample problem again on the RL circuit. Remember. So my next videos I will be looking on the RC circuit and how to derive it. So I want us to put in mind this equation. So remember in my video when I was introducing the concept of electrical circuit, we calculated and solved for a non-homogeneous equation, and we got current as a function of time equal we got it as E of t upon R into 1 minus E raised to negative R all over LT. Okay, so let's keep this in mind. I will be using these at a certain point to this question. So we're saying in the figure below, L, so this is the figure below. So this is L, this is R, and then this is E, should give us 40. Then determine an equation which expresses the current as a function of time, assuming the I of t equals 0. So this is our initial condition. Okay. So another thing that maybe you need to know, we haven't labeled this symbol, so you should know these are resistor, okay, and then you should know this is an inductor. So an inductor is an inductor is represented as this, okay. So this is an inductor. A resistor is represented as either this or uh, this, okay. If I take this resistor and indicate a line this way, so this shows this is a variable resistor, okay. For this case, for example, so this is a variable resistor. So keep in mind with most of the electrical symbol. So yes, it's not a physics course, but just get conversant with them. So we are saying these are initial condition. So these are resistor. Keep in mind these are an inductor. So this is an RL series circuit. Okay. So we are saying our first step is to originally have the first order homogeneous ordinary differential equation. Okay, that we had gotten from the Kirchhoff's voltage law. We said it was L delta I upon delta T plus it was plus Ri, okay, should equal plus IR should be equal ET. Okay, so this was our first order homogeneous ordinary differential equation, which we will solve using we'll solve this equation using an integrating factor. Okay, so using an integrating factor. The reason behind it is because it's linear and it's first order. Okay, so we'll use the methods of integrating factor to solve for this. So let's replace our information. So we are saying L is 2 multiplied by di upon dt plus R is 10 multiplied by I should equal 40. Okay, should equal 40. So from that point we have substituted our information. So we are saying this should equal to 40. Okay, so let's divide by 2. So dividing by 2, I'll get di upon dt. Okay, should equal 5I equal 20. Okay, this should be positive. Okay, so don't worry. So this should be positive. So from this point we have arranged this equation in terms of the general form of a linear ordinary differential equation. So first step, we are saying let's get our integrating factor mu of x, which will equal e raised to the integral of, automatically this will be our p of x. Okay, our p of x. So I should put 5 at this point, but because it's our current, we're integrating with respect to time, so delta t. Okay, so if I take this integral, I should get 5x. Okay, 5t, not 5x. Okay, so be conversant with it. So we are saying we should get 5 multiplied by the integral of dt. Okay, so if I take this, simplify, I should get 5t plus a constant t, of which I won't include this at the moment. So it's saying e raised to the, this integral we have already evaluated it. So evaluating this integral, we have gotten 5t. Okay, so that's our answer. So it's 5t as our mu of x. Okay, so for us to solve for this differential equation, we should take the integrating factor and multiply it through to all terms in the differential equation. So we are saying e raised to 5t multiplied by di upon dt plus e raised to 5t multiplied by 5I should give me 20 multiplied by e raised to 5t. Okay, so how will we operate from this point? As you can see, this is just the product rule, and we have taken the derivative. So I can say this d dt. Okay, d dt of the exponential to the 5t multiplied by I should give me 20 multiplied by e raised to 5t. Okay, at this point, let's take the integral of both sides for us to get our answer. So if I take the integral of both sides and get I multiplied by e raised to 5t, should give me 20 multiplied by the integral of e raised to 5t dt. Remember, because it's a function of time. So from this point, I'll direct you on how to integrate exponential functions. So for this case, it's just 20 multiplied by e raised to 5t, then differentiate the the power to this exponential. Okay, so differentiate this power, then divide by the derivative. Okay, so how to integrate this, go check. So we're saying if we divide this, if I clean it up a bit, we are saying this is 4 multiplied by e raised to 5t. Okay, so that's my answer. So I'm saying my answer is I multiplied by e raised to 5t should give me 4 multiplied by e raised to 5t. Okay, so from that point, for us to get, and remember, we have integrated this, so it should include the constant of integration. Okay, so from this point, let's get our I, because we are looking I as a function of t. So we'll divide by e raised to 5t, divide by e raised to 5t, and divide this by e raised to 5t. Okay, so if I divide that, I should get I should give me, this will go with this, should get 4, and plus c multiplied by e raised to negative of 5t. Okay, so from this point, this is our general, so this is our general solution. Okay, so in this general solution, we should include the initial function, the initial condition. So if I bring in the initial condition, so the initial condition stated that if I of 0 should equal 0, so this simply means I of t equals 0. So t equals 0 and I should equal 0. Okay, so from this point, we are saying substitute back inside the integral for you to get the value of c. So I should get 0 equal 4 plus c multiplied by e raised to 0, which is 1. Okay, so from this point, I should get c equals to negative 4. So if I take it back, I should get I should give me 4 minus 4 e raised to negative 5. Okay, raised to negative 5t. Okay, so should raise to negative 5t. So if I take the 4 out, I should get I should equal 4 into 1 minus e raised to negative 5t. So I want to give a relation. So this is our particular solution. Okay, so I want to make work easy and simple. So remember my equation. We said when we were solving this equation, our first equation, we derived the expression. So this is the expression that we had derived. So this expression is what we had earlier on derived. Okay, so this expression simplifies our answer. So if maybe time gets you while you're doing this process, you can just take this expression and substitute your answer to it, and you will get your answer. Remember, we are deriving uh, this formula. Okay, so we are saying I as a function of time. Okay, we are saying, so let me say, so this is just another concept. I as a function of time should give me e of t divided by, it was r. Okay, into 1 minus e raised to negative r all over l t. Okay, so if you are late with time, you can just simply get your answer as, what's my e 40 divided by my r. What was my r? My r was 10. Okay, into 1 minus e raised to, what's my r? 10 upon 2. It was my l t. Okay, so if I simplify this, I should get 4 into 1 minus e raised to negative, remember there's a negative at this point, negative 5t. Okay, so this is my answer. So these are my answer. I as a function of time, I should get it as 4 into 1 minus e raised to negative 5t. As you can see, we have gotten our answer. As you can see, we have gotten our answer. So this answer, you can keep the relation with this answer. So this is a quick way to maybe compare your answer. Okay, so as you can see, these are the function. So this is a function of time. I as a function of t. Okay, I as a function of t should get this. So this is same particular answer we have gotten to this side. So go check again the derivation of that formula, of this formula. So check the derivation. Okay, and maybe possibly memorize it. Now we have two questions are these. So our second equation, we are saying what is the current after 0.1 seconds. Okay, so we should find the current after 0.1 seconds. So let's calculate that. So we have our function, our particular solution. Okay, so having this particular solution, we are saying let's find current if the time is 0.1 seconds. Okay, so it should be 4 into 1 minus e raised to negative 5 multiplied by 0.1. Okay, so we are saying once we calculate this, we should get our I as a function of t equal 4 into 1 minus, if I operate this, I should get 0.60653. Okay, so if I continue that, then I'll say should equal 4 into 1 minus this, I should get 0.39347. Okay, so I should get my answer as, multiply that answer by 4, I should get 1.57388, and it's in this current, so this should be ampere. So Please check all the SI units well. Please like, share, and subscribe to my channel, and have a lovely day.